And what we're going to do on this one more day is basically backwards from yesterday, which is to write a quadratic, or as I kind of call it up here, 3 ways to parabola, trying to use the word parabola like a verb, but basically we're going to make a connection today. I do like to say, because it's true, that we're not doing anything new today, except that we're going to realize that we actually have 3 ways to do a parabola. And really the main idea today is for you to walk out of here realizing, oh my gosh, yes, we have these 3 methods. All of them we've talked about over the last couple months, maybe other years, but we just want to sort of put them all together today. Now, to help us think about these 3 methods, let's sketch a parabola over here. It really doesn't matter exactly what it looks like, but I'm going to kind of stick it a little bit lopsided. That's really not a good drawing. Let's try that one more time. Okay. There we go. What I'm trying to do is get us a parabola that we can focus on some points, which will kind of lead us to some of these methods. So as I'm trying to show you here, we have a vertex, and most of the time we call a vertex H and K, although you could use any letters you want. And why would we be thinking about the vertex? Well, because of the vertex method. And the vertex method is basically to use H and K to be able to come up with an equation of the form y equals a times x plus or minus h squared plus or minus k. Oh, it kind of looks like vertex form from yesterday. But the idea is if you have the vertex, you could plug it into vertex form and you'll have an equation. So I got you started. What about if we had the roots? What about if we had the roots? We'll call them R1 and R2, kind of fittingly for each root. How would you write an equation if you had the roots? What if I told you, how would you write an equation if you had the factors? As we're going to kind of call this the roots slash factors method. The hope is that you'll make a connection and realize that that's how we were kind of doing problems in the last chapter. We called them polynomials. This one just happens to be, is only going to be of degree 2 because I'm only going to have 2 factors. That would be x plus or minus r1 and x plus or minus r2. Now don't forget the letter a in front, but that's certainly another way to write an equation, again using the factors or the roots. But there's 3 methods for parabolas. This one's a little more specialized to this year. It would have been something that I actually did with you. We took a whole day, at least part of a day, and talked about it. How about the idea that a matrix slash 3 points make a parabola? Again, using a matrix and the idea that 3 points make a parabola. Well, sure, we could do that, and we'll end up with an equation, just to kind of jog your memory, of the form x squared plus bx plus c. Now, if you're saying, well, why would I want 3 methods? Well, it might depend on what you're given. And like I said, we're also just trying to make a connection. So some of today is to realize that all 3 of these methods should give us the same answer. Hold that thought. As I said, they should give us the same answer. Let's do letter A. We'll kind of do it together. If at any point you kind of feel like you can go off on your own, don't let me hold you back. I'm going to ask you to do letter B, so let's do letter A together. Okay. Now, if we're going to use the vertex method, it would be helpful if we had the vertex. And just a little bit of careful counting, you hopefully deduce that it's at 1, -4. Now, the interesting thing about the vertex method that I want you to just kind of note is that it only uses 1 point. But that 1 point, we might argue, is the most important point. So if I take the vertex and I carefully plug it in for h and k, it's probably not a big surprise. You've done this kind of thing before. We end up saying that we're going to shift to the right. That's why we use a -1. And we shift down. That's why we use a -4. And ta-da, we have an equation. Now, one thing we like to do when we get these equations is to write them in standard form. It's just, as it says, it's standard. So that would mean that you'd have to FOIL and do a little bit of simplifying of combining like terms. Maybe you can do some of that in your head, but basically we're going to FOIL and subtract 4, and we'll end up with a more of a standard looking equation of the form x squared minus 2x minus 3. Looks like a parabola to me. Good.
How do we check A? Or just do we automatically implement one?
Well, I'm going to sort of purposely not answer that question as I'm not trying to be a rude, but it's actually something I'm going to let you guys kind of discover a little bit in problem B. Okay, but it's a great question. You should be like wondering what's up with A. Now, I guess I'm not going to straight just not answer it, because look, when we do method 2, and when we do method 3, we're going to notice something in this problem. So let's keep going. I guess if we're going to do method 2, we need some roots, right? And again, the problem's kind of made nicely for us to be able to notice that this root is at -1 and this root's over here at 3. So that's nice. They're integers, and we can use them to our full advantage as you write out the factors. I hope you're writing x plus 1 and x minus 3. Now, notice when you use the roots method that we're using 2 points. Every time we do a method, we seem to use more points. So this one uses 2 points. Like I said, we like standard form because standard form is we're able to compare. And do you see what happens as you FOIL this out? Don't take my word for it. Make sure you FOIL it out. And you get x squared minus 2x minus 3. Okay, maybe that's what you expect to happen, that you get the same answer. And then we arrive at method 3. How many points are used in method 3? Well, of course, 3 points. Okay, you would think that the more points you use, the better the answer. Also, the more points you use, the more work that you have to do. Now, students do sort of notice or say, do I have to do this? Well, I don't know. Do you have to? I'm going to remind you of this method. All we're really going to do is plug in for x and y. And when I plug in for x and y, I'm taking each one of the points, and I'm basically substituting them into ax squared plus bx plus c. It's kind of a special method. It's kind of one of those things that at the time you probably were good at it, but you can still be good at this. I just plugged in -1 for x and 0 for y. I'm just using the same 3 points that we already found. There's no reason to find new points. And then you can plug in the vertex. If you're just wrapping around the parabola counterclockwise, you would plug in the vertex for x and y. Now remember, when you plug it in for x and y, A, B, and C, they don't change, because that's, of course, what you're solving for. Okay, make sure you do what's helpful to you. I mean, you can look up here, but I encourage you to think about at least doing one of these on your own. But I am just plugging in each of those 3 points for x and y. Okay, each of these equations should sort of be simplified or at least kind of rethought as something a little bit more natural. This one, if I kind of just do the math, I get a minus b plus c equals 0. And if I keep doing the math, being careful with the ones and the negatives, we end up with 3 equations that kind of look like a matrix. Of course, because they are, at least they can become a matrix. And we have a moment. If you so desire, you could practice that matrix thing. It's kind of helpful to get the answer and just see for your own self how that answer relates to the other 2 equations. Again, it doesn't take long for people to say this takes more time, but it does use all 3 points. And you would think that the more points you use, the more accurate your equation. But of course, we really come up with the same 3 numbers. And I just want you to make that connection here that when you get 1, -2, and -3, that's, of course, A, B, and C. A, B, and C. Now, it seems like that all 3 methods work. Well, they should. But there's a little more to this. As was asked, what about the A value? What about, the dilation number? I want you to experience example B. I want all of you to experience all 3 methods for example B. But I'd like to assign you one of the methods to kind of specialize in because, well, could I ask you then in like a little group of people to just talk about it, and then eventually we'd like to get a little workup on the board. So I want you to do all 3 methods, but if I could ask you to kind of specialize with some people that are sort of nearby, is that all right? How about you 4 fine folks? I'm going to ask you to sort of specialize in method 1. Okay, maybe you already started method 1. Do all the methods, but specialize in that one. How about you find 3 young ladies? Can you specialize in method 2? Whether you want to do that first or just I want you to talk about that one. I'm going to give you guys method 3 kind of on purpose because when you go to the calculator, can one of you use my calculator? Now, talk about it, compare it, and then stick it in here, please, into the matrix. I'll meet you back here in a couple minutes. There's something that we are going to want to, as a full class, we're going to want to notice about letter B. Did you get a chance to experience as many methods as possible? Do you feel like that there's something about this problem that's not quite all matching up? Now, of course, the one reason maybe we like math, at least I know I do, is because there usually is only one right answer. I mean, sometimes there's a couple answers that are right. We need them all. But clearly in a problem like this, not all 3 of these equations can be right. Okay, if you would graph them, you would see that some of them do and some of them don't look like the parabola on the paper. And I know you guys are smart enough to realize that the numbers are different. So something needs cleared up here. Now, I said it a couple times to kind of get you guys to sort of realize that, geez, if you're using 3 points, that seems like that would have to be the best way because 3 points make a parabola. So if I'm using 3, you would think that I would be able to create that equation most accurately. And so just to settle things once and for all, the right answer is negative 2x squared minus 8x plus 10. So that is the right answer. But can we get the right answer? Can we fix these problems so that we can also use the roots method to end up with negative 2x squared minus 8x plus 10?
I really messed it up. I don't know what I did.
Let me, just because of the shorter period, maybe be able to come back and look at your calculator at the end there. You'll get it, but make sure that you this is kind of the main thing here, to realize how to fix these answers, and then I'll help you fix that. Look at this roots method. Let's be in agreement that this roots method used 2 points. 2 points ain't bad. Okay, and the interesting thing about these 2 points is that they leave us with the ability to notice the y-intercept. Now, this, of course, is supposed to be the y-intercept. So the question kind of is, how can we make negative 5 become what it's supposed to be? What could you multiply by so you could fix this equation? Okay, well, if you look at this y-intercept, you would say that you could multiply it by negative 2. Now, maybe you realize, well, geez, that's kind of what this equation already says, but do you agree with me that this equation, if it was fixed by an a value, and really what's happening here, folks, is there's an a value that's always been in front of these factors. We're just now going to think about it. And all you got to do is think about the y-intercept. So to say that a equals negative 2 is smart and right because, again, it fixes the y-intercept. Okay, so we can salvage the roots method. And I'll share with you that this always works. It always works that you can just look at the y-intercept, which takes us over here to the sort of the vertex method. Now, the vertex, it's the most important point, but it is only 1 point. And so we kind of have to be really sensitive to dilation. And it's more of a timing issue with the dilation. Now, again, I hope we realize that a equals negative 2, whether it's from the third method, the second method, or now over here. But you should be asking, well, how would I get that if I didn't know? And so here's kind of I'll sort of say the bad news. You can't do the foiling. You can't do the foiling and expect to get the a value because of the order of operations. Instead, what I need to do is I need to start with this formula and then go back to some good basic algebra, which says I can plug in a point. And so you can always plug a point in for x and y. That's the beauty of algebra. Any point you want, folks, any point you want. Y-intercepts are nice because they're usually, well, every graph has them. And they also involve the number 0, which, if you don't mind the number 0, it might make for some easy math. What I'm doing here is I'm solving for a, and just quite frankly, I have to do it from the beginning. Now, as was asked a few minutes ago, how do I know? And I think the answer is you actually should always be aware of it, meaning I really should actually be solving for a every time by plugging in a point and then doing the math to get, well, in this problem, to get a equals negative 2, but we already kind of knew that. Unless you're going to use the roots method, which actually allows you just to look at the y-intercept, unless you're going to use 3 points to make a parabola, which always works. If you get it typed in, did you figure out what it was? Now remember, today is all about making a connection. All 3 of these things you've seen at some time, place, but make sure that they are tools that you're as comfortable with as you are with y equals mx plus b. You know, we want you to be comfortable with quadratics, that is parabolas. And so I think we have a couple conclusions on the back. I think that'd be helpful to fill those in. But really, when it comes down to it, what method are you going to pick? Which one are you kind of comfortable with? Because when you're solving for A in the vertex method, as I tried to show in this problem, you have to make sure that you realize that the A only applies to the x plus or minus h squared. Again, the letter A is only in front of that first quantity. I like the roots method on a personal note. Okay, I like the roots method, okay, because it does use 2 points, and all you really have to do then is just check the y-intercept and see if you have to multiply it by some letter A. So again, you can look at the y-intercept. When I say look at the y-intercept, I mean look at it on the graph, and you can just kind of fix your equation. Of course, 3 points always make a parabola. In other words, that's fail-safe. It'll work every time. Be careful. I actually don't want you to only use one of these methods and sort of bag the other two. I'd like you to be comfortable with all 3 methods because they each have sort of their place. And that's what the homework questions are supposed to get you to do. Okay, so try to use at least each method once. And then I kind of make you, at least I ask you to use, on one of the problems, I ask you to use a couple methods so you can see that you get the same answer.